So I'd like to welcome all of you, and thank you, Andy and Lars from Xailient, for joining us at the tinyML Builds. Our strategic partners are AIZip, Analog Devices, Windows blocking me, Arduino, ARM, BrainChip, Edge Impulse, Greenwaves, Groveti, IBM, Magimob, Infineon, Innovators, Microsoft, Nota AI, NXP, Polygon Technologies, Kixo, Qualcomm, Renesas, Schneider Electric, tinyML, Sony, Silicon Labs, ST, Synaptics, and Xailient. Would like to encourage all of you to join our fast-growing community. We have meetups, local meetups, as well as meetups that are, as well as these kinds of seminars that are live. If there is not a meetup in your area, I would encourage you to start one. We're starting one in the Southern California area, for example. There's also the tinyML community on LinkedIn. So please join these and join us together. There's also a pretty large YouTube channel, and this seminar will also be put on there. So there's a lot of content, very, very specialized and quite detailed stuff that hopefully will help all of you. There is the next conference coming up, Europe, Middle East, Asia at Amsterdam. Please go ahead and register for it. It should be really wonderful there. So, the link is out here. You can also go to the tinyML.org, and the link is up on the website to register for that. I'm Venkatrangan, founder of TinyVision, and I like building stuff. And we're starting this series to look at really the various technologies that people would like to use when they build things. So this is hopefully a conversation that can help all of you. With that, I'd like to introduce our guests today. Lars is the CEO and co-founder of Xailient. He's got a lot of experience with multiple companies. Thank you very much for coming.
Pleasure.
Andy is the VP of Engineering and has a lot of experience, a lot of projects as well. And so looks like we have excellent team here. So we'd like to dive into this. I'll stop sharing, and then we can go into a little bit of start with the background about Xailient. What is it that you guys do, and then maybe we can dig into some of the details.
Yeah, sure. Thanks, Venkat. I'll do this really just briefly to kind of make sure that everybody kind of has a framing of where we're coming from, right? Because obviously I think we're all eager to get into the lessons learned and the repeatability for everybody else. So basically what Xailient has done is build a solution for customers to deploy computer vision to the edge. And that became a lot more complicated than we realized as we go. And I'll sort of talk about that in a second, but where we are right now. So we have the complete solution that allows customers to create or take a pre-trained AI, deploy that into cameras itself. And I mean, we're talking tiny little systems like this one this is from Analog Devices. This is the Sony camera. This is a complete camera. This is one of the Taiwanese partners I can't name yet. This is the actual product. So this is a complete video doorbell from Abode using the Ingenic T31 chip, and we do face recognition on that system as well. So kind of all of those types of technologies deployed onto the camera itself, right? So you can run the AI literally at the edge and just send back whatever the result is. What we learned as we went was that actually there's a lot more that you need to make that practical, right? You need to be able to diagnose issues and monitor performance in the field in real time. You need to be able to create updates and push those updates back out to those cameras, right? So the classic use case here is, you know, let's say you've launched a new consumer electronics product and everybody loved it. They bought it on Cyber Monday, they put it under the tree, and Christmas morning, everybody buys it, but there's a snowstorm, right? And now all of a sudden, all your customers in New England are reporting low accuracy, calling up your customer support line because your team in California and Taipei didn't think about snowstorms. So typically that would lead to a return, right? And maybe getting knocked off the shelves at Walmart or Costco or any of those guys that don't like that reverse logistics. With manageability and with our product Orchestrait, what you can do is see those problems, identify the cameras that are having issues, collect imagery off those cameras, train an updated AI, and push it back out, right? So now January or December 27, boom, all those customers are working again, and you get that customer service 5-star review rather than the, oh, it didn't work, but instead I had problems, I called them and they fixed it, right? So you can really kind of bring these edge AI systems up to the expectations that customers have nowadays for the systems that they buy, right? Because they're used to the cloud response times. So that manageability of the edge. Now that introduces a new challenge, because if we're going to collect data off the edge and use it to run tests, run audits, train AI, you need to have consent from anybody that's been depicted in those images. And so enforcing that consent and monitoring the data as it flows and through the entire life cycle so that you have known provenance of your training data, known provenance of your testing data, that's kind of the last element of our product. And so that's the compliance and privacy assurance that we provide. And so companies can create policies. Those policies then are mapped onto the different geographies because there's different rules in different jurisdictions. And we manage that for customers and put out regular updates so that they can keep up with regulations and be in compliance kind of globally with their AI in the field. So it's that complete solution to actually get edge computer vision working in production. So anyway, that's and that's available on lots of different cameras. You can see the hardware partners along the bottom there. I think kind of maybe what's more interesting for this audience and more repeatable, right, is the journey that we went on. So Xailient is about 4 years old, or just coming up on our 4th birthday in August. And we spawned out of academia. So my co-founder is an academic. He invented tinyML algorithms. They were dramatically more efficient than the state of the art. And it took us some time to really figure out how to commercialize that. Like, where are we going to make money? Early in our journey, we had some really exciting commercial POCs. And I'm thinking of one in particular where we sat down with a customer and we demonstrated to them, and they agreed, right, that we were going to be able to save them a lot of money in their cloud bill. I mean, 80, 90% plus, right, on their AI expenditure in the cloud. And ultimately, they didn't purchase. So we had this really great conversation, and they were really friendly and gave us the feedback and sort of said, look, at the end of the day, this doesn't move the needle for us because we still have to upload that data. We still have to store that data. We still have to have egress on the results of that data. And so while it had a big economic benefit, what they really said was actually what we think we need to do is we need to move to the edge. Right. And so this was early days, right? And that was kind of when we discovered we needed to move to the edge. And so then we got a lot of lessons and working with hardware and starting to understand how do you actually execute AI at the edge rather than just make AI smaller. And I think Andy is going to have a lot to share about that experience, because that's doing that in practice is a lot harder than it looks. So once we sort of had that, then we discovered this need for the manageability, right? And we invented the CV Ops platform, which is our name for it. That it's a bit of ML ops, it's a bit of data ops, but specifically for computer vision, because you also want to collect data about the sensor itself, right? So you want to know what's the exposure on the camera, right? What was the focal distance? All those kinds of things that that help you inform your accuracy and your performance. Around that point, we started to say, okay, where's the repeatability? Where's the market growing? And that's really when we honed in on the residential space and sort of video doorbells and security surveillance around single family residences. And now we're moving up to larger residences and multi-dwelling units and access control and things like that. But we really honed in on something very specific where we had, that classic crossing the chasm, small enough that we could actually conquer it, large enough to be interesting commercial opportunity. And along that way, discovered, or realized that the challenge of privacy is not just privacy by design, which is kind of what we were all talking about, and not just privacy in fact, but proving that, right? And demonstrating to boards and to digital privacy officers that they are in fact obeying the rules in all the jurisdictions in which they want to operate. Because some of these jurisdictions have liabilities not just for the company, but for the individuals. And so that was sort of the ultimate layer that we added to the product.
Okay.
So yeah, that's where we are.
There were a lot of things I'd like to unpack there. So you talked about a few things. There was privacy and regulation seems to be the major aspect here, but there's also the whole journey that you talked about, which is you started off as an algorithm company, and somehow you figured out that you wanted to go into all these different things. So you also talked about something as being auditable, and the deployment and field updates. All of these are really important things. So perhaps it would make sense for us to dig into some of these things. What does it mean? What is privacy really in the CV space that you are specifically in? For a doorbell, what does privacy mean? And how do you do that?
Yeah, that's a really interesting question. And I think it's a bit of, eye of the beholder, right? So we talk about it in different layers. And I think the Future of Privacy Forum, of which we're a member, has a lot of really good thought leadership on this, and they've informed a lot of the regulation. So one of the things that we do is we work very closely. One of our advisors is a fellow at the Future of Privacy Forum. We're members, right? And we work really closely to understand the thought leadership on this, and not just the regulation. So ultimately, I think for me, it's about consent, and it's about the purpose behind that consent. So I think we've seen a few, we all know sort of the examples of like, you're hit with a 40-page document, that changes every week, and you have to click through it to then.
And nobody reads it.
Yeah, right. I mean, and the thing is like, that's not genuine consent. And now the regulators are catching up with that frustration, right? So we're now starting to see in a lot of places that is not considered genuine consent anymore, and the legal frameworks don't acknowledge that. So that's no longer a shield for companies. And some of those jurisdictions have allowances for data that's old enough, right? So they sort of say, okay, before January 1, 2021, right? We'll like pretend that didn't happen. But now if you're collecting data now and you're still doing that, you are going to run into trouble, right? So and maybe let me kind of go back to your question around what the privacy is, then we can talk about the regulation and the impact of that and the risk for a company. When I give consent, right, and let's say I say, I'm going to allow you to take photographs of the front of my house so that you can tell me if somebody's approaching the front of my house, right? That does not mean that you should then also use that data to improve your product without my permission. It does not mean that you should sell that data to my insurance company or to post it on CNN because somebody in the street outside my house did something silly, right? My consent was for you to take those images and route them to me. That's what I consented to. That purpose of surveilling my home for security, that's my purpose. That's all you should be allowed to do.
So it is also, it is how you use the the data, it is not just you're collecting the data, but also you're consenting to only a very specific use case.
Right, right. And in the law, it's called purpose, right? And so, the best practice now is UX during, somewhere along the journey for the customer where they're clearly explained what they're consenting to, and it's atomized. And we see this in websites that have some of those GDPR consents now, right? Where, hey, do you allow me to do this? Do you allow me to do this? And it's atomic, right? And so now, if you've got an enthusiast community and you kind of recruit them in, people will opt in, right?
Yes.
So now you've got genuine consent, and you can use that data to improve your product. It's the best practice here is pretty clear. Implementing it is challenging.
So you mentioned risks to companies as well. So let's assume that I'm building a product, right? Something like a doorbell or a camera that sits around and monitors my kids, for example.
Yeah.
What are some things developers of these sorts of products should be aware of as far as risk?
Yeah. So I think there's two layers that you want to think about, right? And the first layer is the real time, what am I doing right now? And is that okay? Right. So, and I think most developers are probably on top of that, right? That's pretty close to the cybersecurity training we've all had for a couple of decades now of, let me make sure that if I'm taking video of somebody's house that, only that person is watching that video. But I think the looming risk, right, is that we say, oh, well, somewhere in that EULA or somewhere along the way, somebody made the decision to collect that data so we could improve our product, right? Or maybe we're going to give it to our QA team so they can double check things, right? Or we have a supervising algorithm that's going to audit and double check what the primary algorithm is doing. Those were not necessarily things to which that person consented, right? And so you're collecting that data and you're saying, oh, but it's secure. I've encrypted it. I put it in a place, only the 3 people are allowed to see it or something like that. And so it's easy to kind of accidentally start collecting a bunch of data that seems harmless at the moment. In Illinois, each of those is potentially a $10,000 violation of the law. And it gets pretty complex, right? So in a lot of other places, there are fines that are either not capped or, otherwise defined. But that data set becomes a looming liability. So, some of us, I think, maybe recall a couple of years ago when some of the big companies, IBM and Facebook, deleted massive training data sets. And the reason was that they could not demonstrate the provenance of that data. So this thing that they thought of as potentially hundreds of millions of dollars worth of asset for the company was actually a liability for the company. And it was a better move to delete it before anybody came hunting for them. And so I think for startups, right, like we all live, especially small companies, you kind of live on the bleeding edge, right? And it's, there's a great How I Built This podcast, right, where he talks about, a good startup is a little bit of a pirate. And yeah, you could be a little bit of a pirate, but you got to recognize that if you're accumulating this data, sooner or later, right, this is going to become a really big liability for you. And investors and customers are waking up to that. So when you go into any kind of serious diligence process and you're trying to sell AI, they're going to ask you where your data came from. And if you don't have a really good answer for them, you're going to collapse, right? And potentially the years of work that you've done are all going to go poof. And that wasn't the rule set 3 years ago, but that's the rule set today.
Okay. I think that's very clear then. The other thing you mentioned was auditable. So does auditable mean that you have a kind of effectively a chain of like, where did the data come from? Who gave permission? And we are using it for only that purpose and no other? Is that what auditable means?
Yeah. So the advantage of Edge AI is that you can make a bunch of decisions in real time at the moment before collection. So let's say that, the 3 of us are sitting in one space, right, together, and maybe I'm on the enthusiast list and Andy's on the enthusiast list. So our identities have been sent down to this camera, in a safe way, and sort of said, hey, if Lars or Andy's in the photograph, they've given consent for that photograph to be collected, but maybe Venkat, you didn't, right? You're a more private person. So when the camera takes that photograph, it's going to see 3 people. It's going to be able to in a de-identified way, say that, person number 1 has consented, person number 2 has consented, person number 3 I don't recognize, and so hence has probably not consented. What do I do, right? And that metadata can be used in real time at the camera. That metadata could be carried with a video stream or an image stream, right, depending on your use case. And then you can apply that given your rule set, right? So if you're a big government surveillance operation and you've got blanket permission to do whatever you want on your space, fine, you've got that and you're going to do what you're going to do. If you're in GDPR countries, maybe you need to redact that data before you collect it, right? And if you're, doing some kind of casual thing in a commercial setting, what you probably want to do is not collect the data at all, right? And then, and that way, later, when somebody comes to you and says, "Oh, hey, you built this AI, you've got 1 million data points. Where did they come from?" Right now, oh, I had consent from all the people at the moment that data was collected, and I've got the trail that proves it.
And also, I guess, because you knew the process of getting to the machine that labeled it, you have access to that machine. You can prove that this is the trail, right? This is not somebody sitting somewhere and labeling every frame. It just doesn't scale properly.
Right, yeah. I mean, labeling is its own. That's its own hard animal. I'm sure, like anybody who's got scars, can talk about that. We've all got the labeling scars, but yeah.
Okay. I'd like to pause and just give a shout out to people who are attending. Please put your questions up if you have any questions. The other thing that came to mind was the deployment and field updates you mentioned about, like the snowstorm thing. Do you want to kind of go over how you manage that and what are good lessons learned from that?
Oof. I mean, some of that's pretty deep technical stuff that maybe this is a good time for Andy to step in on the how. I mean, I think the big picture lesson learned while he unmutes is you've got to do it, right? Like lab results and real world results don't really map. I think there's a report from Gartner that 47% of AI models are never deployed, right? So basically enterprises have a roughly half success rate with AI. And anecdotally, I think a big part of that is disappointment with the actual result in field when people play with this stuff, right? You can play with your toy data set and get to a point. And convince yourself that it's great, and maybe even have marketing that says how great it is and get people to accept it. But if you can't survive that first year in the field, that doesn't matter, right? Because that evaporates pretty quickly. As to the how, I'll let Andy speak to that.
Yeah, so one of the interesting challenges, and there's some slides that are coming up later that will touch on this in a bit more detail. If you look at what we're trying to do with AI at the edge, and particularly when it's blended with IoT, we're intentionally taking something that is very complex. We're putting it onto tens of thousands, ideally hundreds of thousands, ideally millions of devices. And because it's, the Internet of Things at the edge, we're deliberately putting these in places where we aren't going to see these devices potentially ever again. We'll never lay our hands on them. So how do you know what they're doing? How do you know they're doing the right thing? So you have to build a system, a tool, ultimately, that allows you to see what these devices are seeing, gather the salient data, be able to run the analytics to see what they're doing. And ultimately, when it comes down to, is the product working or not, There's the analytics around, functional and performance. Is the product performing to its key performance parameters, from the strictest engineering sense, but also a mechanism whereby you can get maybe more subjective data from, again, hundreds of thousands of end consumers around, is it meeting their quality expectations? And so, as Lars talked about on the opening slides, it's not enough for Xailient to come up with an algorithm. It's not enough just to take that algorithm and put it onto a $5 chip and hook it up to a camera module and put it in a box. The responsible thing to do is we've got to build a system that allows our end customers to know that the solution that we've given them is operating out there in the field, 365, 24/7 at scale. And that is where a large part of the complexity lies, because the product may be in development for 6 to 9 months. It's out in the field for 5 to 10 years. So you've got to have the mechanism to be able to look after those devices whilst they're out there in the fields doing their thing.
Okay, and I think there's a lot of when we were preparing for this talk, there was you gave the analogy of an iceberg. There's this all the little stuff that we see from the surface, and there's a whole bunch of stuff below, right? I think that would be great if we can dig a little bit into that, which is just the easy stuff that companies start off, or an enthusiast might start off in the space and say, hey, I have a cool model. Now I think I can go build a product. But there's this big gap to cross.
Yeah.
So if you're, sorry, go on, Lars.
No, go ahead, Andy. Go ahead.
So if you, that's potentially a good segue into some of the things that I wanted to share this morning. So you okay if I share my screen?
Yeah, fire away.
Okay, great. Okay. So first of all, I'm no artist. Okay, so I am not for hire to produce slide decks. This is very much the engineer's visual representation. So just quick disclaimer. So on my intro slide, it mentioned lots of products, worked with lots of customers over many years, but the last line on my profile, I think, really sort of reveals a lot about me. My interest is about developing engineering solutions that will actually get out there into the field, and they'll be impactful in some shape or form over some period of time, and delivering value to people. And when we think about technology adoption cycles, we think about innovation processes, and this notion of crossing the chasm. We have to have a way to be able to get these AI solutions out of the lab, off of the bench, getting out of this loop that I think is very easy to get into of, we develop a POC, everyone high fives, this is cool technology, we go to a trade show, we show it off, we come back, we have a bit of a follow-up about what we learned at the trade show, and then we improve our POC and we go to the next trade show. Yeah, that's very different from, we're actually engaging with brand customers, and we're deploying tens of thousands, hundreds of thousands, maybe even millions of devices, and we're generating business revenue from this, and we've got a successful product which is delivering impact into the field. Yeah.
Hey, Andy, I think, sorry to interrupt you. If you do your little flip, because we're getting your presenter screen instead of your full screen, which is fine for your beautiful artwork. But I think on your next one, your table, you're going to want the detail. But I think while you're pecking at that, I cannot reiterate and stress enough as a founder to any other founders or prospective founders out there, the risk of this trap on the left. It is really easy to operate in communities where you get a lot of positive reinforcement around the wins that you are securing, but they are not the wins that are getting you across this chasm. And it's really, really easy to be in an echo chamber accidentally, or to kind of put yourself into an echo chamber because that's where you're getting the positive feedback, right? And founder advice is chase your wins, right? So it's really easy to be chasing the wrong wins.
Is there something specific about your product, for example, where you might have gotten stuck in one of these echo chambers, perhaps, or were you able to recognize that quickly and move forward?
It's a really interesting question, Venkat, and probably better answered by like one of our board members than by
Okay.
I mean, look, I think every CEO wants to be moving faster and looks back at the last period, whatever that was, 3 months, 6 months, a year, 3 years, and says, oh, if I had done this, and this differently, we'd be moving faster. So absolutely, right? And some of that inefficiency is unavoidable, right? So you know, it is what it is. But yeah, I mean, look, the only advice I can give on this is just to be aware of it and keep kind of putting your head up and asking yourself really tough questions and surrounding yourself with some very commercial people who can test you, right? And I've been really lucky with both internal and external advice, right? Our management team is built of people with commercial successes who push hard on those, and our, you know, obviously boards and outside advisors usually do too, but I think that's really, really important.
So, sorry, go ahead.
Oh, so I was just going to say that you know, we're you've got to kiss some frogs along the way, right? So you know, it's every successful product. It's not just the technology that gets there. You know, they will have spent some time going around and around, trying different things, etc. And so, you know, feeling like they're potentially stuck over on the little island on the left. And when I've been at Xailient 18 months now. When I turned up, I think the company was emerging from, you know, a little bit of what was over on the left. Like we've got this technology. You know, where are we going to find a spot where it lands? You know, there were many things in the portfolio, and with the folks that we had and that were brought into the company, opportunities started to open up, and we were able to move from the left to the right. And so largely through what we're doing now with the video doorbell side of things. And, you know, if we look at, you know, back to the origins of this crossing the chasm, you know, Geoffrey Moore talks about you've got to do something specific. You've got to set up that beachhead. Don't be like everybody else. You know, what is your point of differentiation? And that journey that Lars talked about on that slide around, you know, the original invention around the algorithms and the IP, and making that transition to, well, what we're going to do is we're going to use this technology. We're going to go after face recognition, which is quite different. Lots of people were doing object detection. When I walked around at EDS and CES when I first joined, you know, every man and his dog seemed to be doing some flavor of object detection. And we said, well, we're going to do something a bit different. We're going to do something more challenging. We're going to go after face recognition. We're going to put this on $5 chips. So we're deliberately going to go after low cost, high volume markets, largely consumer products. And that was the beachhead that we established. And, you know, as the great testament is, Lars held up a genuine product that is in the field now. There you go. So getting across that and genuinely finding the niche that, you know, when you walk around at EDS and CES and other shows, you can see that, well, we're actually differentiated from the rest of the pack. Find that beachhead.
That brings me to one of the things I wanted to bring up is you guys mentioned some of the scars along the way, especially the hardware scars. So, Andy, would you like to just get a little deep into that? What is it that caused those?
Yes, I mean, so obviously we're Xailient's a software company rather than hardware. But what that means to us, of course, is we've got this rather significant constraint. If I just jump to the next.
Hey, and do you want to go back like 2 slides to where we fit in the ecosystem, just really briefly, just because, one down, just to sort of set the context for the audience, right? So Xailient sells software, but our customers sell hardware and complete services, right? So our partners are the ODMs that manufacture these devices, right? So a company like Abode, right, which sells video doorbells and ongoing customer monitoring services, will buy software from us and hardware from one of our partners, right? So that's sort of how we fit in. And I think again, like if we get back to it, coming back to this and understanding the value that your tinyML adds to each person in the supply chain and how that stacks up is critical on the business side. But I think actually probably the technical stuff is more interesting to this audience. So now we can go back to Andy. I just wanted to make sure that people understood where we are, because we work with a lot of different hardware partners.
Yeah, indeed. Yeah, thanks, Lars. Yeah, so if we think about hardware and what it means for us, Xailient, as an edge AI software provider, we have this rather significant constraint that's hanging over us, which is fine. We can deal with it, but it's there and it has to be acknowledged. And that is for when we've looked at the problem that we're going to try and solve. We've been through the who, what, where, when, why, how. So we've got a good understanding of what it is that we're trying to do. And we're going into a high volume, low cost market. And so, as we know from anyone who's ever designed and built a physical product, somebody sits there with the bill of materials, manufacturing cost of goods, etc., and they're going to go down and they're going to try and shave cents or dollars off of everything. And so, as software providers, we're going to end up on a resource-constrained, low-cost microcontroller, microprocessor. And so, straight away, for anyone who's developing software, but particularly for the computationally intensive side around the AI, the algorithms, the models, we do have these constraints. How much RAM is on that chip? How much flash is on that chip? What are the flops, scops, tops, whatever metric you want to use for just how much grunt do we actually get out of that device? We've got to live within those constraints. And so we then start translating to, well, okay, what models am I allowed to pick? I can't do what everyone else is doing, which is go and grab YOLO, blah, 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 because I literally just cannot get that onto the device. I can go and grab some open source models. Yeah, okay, all right. I can get those working off target. I can create my ensemble, my pipeline of models, and I can get some results. What happens when I put those models through that proprietary processor-specific AI framework and conversion tool? No, look, actually, they don't actually support operations X, Y, Z. These layers won't work. So now I've then got to go and I've got to have the expertise in-house, the capabilities on my team, to take these open source models, start pulling them apart and then putting them back together in a different way so that we can get them through the proprietary converter and then actually get them working on the target hardware. So we haven't actually run anything yet. This is just the pain you've got to go through to get it to the point where I can actually build it, I can deploy it, and I can run it for the very first time. So we haven't gone anywhere near, does it actually work? Am I meeting the functionality, the performance goals? Where do I need to optimize? Was my training data good enough? Was my test data good enough? So this is just getting it to that first port of call of, can I actually get it onto the target hardware?
So this itself is an iterative process, right? So you have something right at the beginning, and then you say, you talk to your potential partners or whoever you're supplying the software to, and they'll say, hey, no, we're going to select this other chip. So that itself is a moving thing. Right?
Yeah, absolutely. So pretty early in the piece, on the slide we're looking at there, and in the get real about the problem and the hardware intersection at that cell, there are early conversations with those people in the supply chain, so that we can understand what the capabilities are of the particular chipset that either they're going to pick, ideally, so we get a chance to influence it, or guess what? It's a legacy product. You know, they've already been in manufacture for 3 to 5 years. They don't want to change it, and so you're stuck with what they've already chosen, and your job is to make
a tremendous amount. Yeah, there's a tremendous amount of inertia around this that I think we underestimated when we started down this journey, right? So we had ideas about customers putting out new products in the field, and that would give us the opportunity to, you know, kind of be on new hardware and you know, pick exactly the best hardware for them, and and the reality is, like, these companies have relationships with ODMs and semiconductor companies that span multiple SKUs, that span over years, right? That have extremely complex evaluation criteria, right? It's not just about the performance criteria of a specific piece of semiconductor, right? It's, you know, do I like the quality control, and is it in a you know, are they manufacturing in places that I can import from, and et cetera, right? So it's, you know, it's super naive, I think, to just go into your lab, grab a piece of hardware off the shelf because you saw a nice, pretty booth at, you know, at Embedded Vision Summit or wherever else, and then say, oh, I've got a complete product, right? Engaging with the customer, really understanding what's going to be a viable supply chain strategy for them, and then getting serious about that hardware really, really early, because the leap, you know, Andy's talking about that leap from it runs in a cloud system or it runs on a GPU, you know, whatever, that leap to actually running on these NPU systems is a big leap. And frankly, I underestimated that as a founder and CEO, right? And I also underestimated the complexity and amount of variability, right? Because all these guys, they put out, they say, oh, we've got a tool chain for TensorFlow Lite, or we've got a tool chain for PyTorch. And you're like, great, if we support those two things, we cover 80% of the market. Yeah. All right. Enter Andy stage left again.
Yeah. So the takeaway there, I guess, is, you know, as you know, Lars just summarized, that jump from the, you know, early stage proof of principle, which is great to do. You know, everyone has to have a reason to believe. So being able to do that with open source, off the shelf, doing that rapidly, putting it on hardware that, you know, it doesn't require a custom build, doesn't require a contract manufacturer to have made anything. It's off the shelf hardware. You know, everybody wants to see something running, you know, whether that's in investors, C-suites, the engineers themselves, potential customers, etc. That's great. Very quickly, it's now, okay, we know, because we've looked to the end, so to the right of what's on my linear slide here, we know that this is not where we're going to make our money. So we've got to very quickly now, okay, get it off this and get it onto that target hardware. And you know, as Lars talked about with regards, you know, underestimating how long that can take. We've seen that take 6 months for some of the chips that we've ported to. We've seen it take 6 weeks. So that engagement with the suppliers to understand, yes, you can send me all the standard documentation that comes with a microcontroller, microprocessor, the application software side of things. Okay, fine. The part that requires most of the attention is, tell us about your AI framework. Which modeling frameworks do you actually support, and how broad is that support? Because what I don't want to do is go and build on my models only to find out that they just won't go through your proprietary converter. So getting things through that pipe and knowing that they will run on the target hardware, that can take quite a chunk of time, which is very wise for, you know, all the technical planners and project managers. Have a nice long bar on your Gantt for that. Don't underestimate what that looks like.
Yeah, and there's existential risk here, right? Because I think one of the things that Andy kind of taught me and taught Xailient when he came on board was getting really specific about what we're trying to prove with each iterative build, right? So it's not just about sort of moving the needle along a spectrum of accuracy or a spectrum of performance or whatever. But being really, really disciplined about what do we need to prove, right? What's the biggest risk? Maybe the biggest risk is it's going to run on this chip. Maybe the biggest risk is whatever, right? And conquering those problems in sequence. And this is, I think, one of the places that I've observed a lot of other companies in our field fall into a trap, because they'll do something like go from an EC2 instance and then say, oh, we'll deploy to the edge and we'll put it on, maybe one of the NVIDIA Xaviers, right? And then we'll put it on a Nano or something like that, right? And you're like, oh, well, we've moved from a $10,000 server to a $500 device to a $99 device, right? So we're moving. Hey, look at this progress, and we can draw this curve and believe that we're going to make it all the way to, a $5 device, right? And the reality is, like, there's a lot of dislinearity that happens along that spectrum, and you can put something on. Not to pick on NVIDIA, right? But you can put something on some NVIDIA devices. You can deploy it into, let's say, a retail store, right? And demonstrate the proof of concept from the business flow perspective, maybe even get some metrics about the business value add. But no doubt that is going to then tell you sort of the ceiling on the unit economics that you need to achieve at scale. And you still have this big looming risk of whether you can come in underneath of that. So you just want to be really, really intentional, I think, about where and how are you going to make profit. And you got to pull that all the way back and start working on those things in parallel. Because otherwise you're just going to, and what we've seen in a lot of these sectors, right, is people deployed things, they were successful at POCs, and then they just never sold product.
So one of the other things that you mentioned was CV ops. I think that was somewhat of a different term than I've heard before.
Well, we coined it. A few folks are using it now, which I think is encouraging. Managing computer vision in production, right, I think is an analogous challenge to any of the DevOps fields, right? The general DevOps, the ML ops, and the data ops, with the specific additional layers around cameras, right? And the hardware of managing your camera. So computer vision, cameras, AI, data, it kind of like there's a lot of stuff there. And frankly, also data provenance and consent, right? Because imagery is a different kind of data, right? It's sort of automatically sensitive, right? I think we should imagine that a photograph is sensitive until proven otherwise, right? Just because if you're taking photographs of spaces with people in them, right, you want to have a precautionary principle. So we sort of framed all of that as CV ops, and I think it's necessary, right? Because if you don't have manageability in production, you don't have a production product, right? You just have a lab toy.
Venkat, let's just keep an eye on the time. There's just two more things I'd love to cover, if that's okay.
Okay. Yeah, go for it, please.
Sure. Okay. All right. So we've talked about having a product that actually delivers impact out in the field, and as we know as engineers, what that means for us is we've got to understand what functionality we're going to deliver, and also the level of performance that we have to hit. What I've always explained to engineers that I've worked with and for, etc., is functionality is a lot easier to hit than performance. Performance is where the rubber really hits the road, and the video doorbell was a really great sort of introduction and eye opener to me, because I don't come from a traditional sort of AI ML background, and when we started to get into so I've got this IoT device out there in the field. Anybody on the face of the planet can own it, so it's going to be in all geographies, and it's attached to their front door, or actually potentially people can also put them in an office building or an MDU, so it's also for use indoors as well. It is 365 24/7 operation, so all sorts of lighting conditions. We're going to see people from all walks of life, all demographic backgrounds. They're going to arrive 10 meters away, they're going to end up a meter away, range, lighting, different modalities. And so for for us to get a successful product out there, we've got to be able to enumerate what actually are the performance targets that we're going to hit. Once we understand what those performance targets are, and everyone's bought into it, said, yep, fine, great, that is the product that we want. This is going to influence one major thing in any AI project, and that's your data. So if you're going to train, where are you going to get training data from that not only just touches that performance envelope, but actually exceeds it, because you're going to want a model that is actually more capable of than just the performance envelope that you want to hit. You want some sort of safety margin, because you probably guessed wrong when you came up with the performance requirements. For a video doorbell in particular, you can't just go out there to, I'll go and grab Coco. I'll go to some open source place and go and grab this data. It literally does not exist. It will get you this far when you actually want to go that far. So one of the key takeaways from today would be plan your data strategy and do it as early as you can, because it's going to take time, it's going to take money, and it's going to require some boots on the ground. It may not be, us directly. You may be asking someone else to go and help build that data set for you. And as Lars talked about, if you're taking pictures or videos of people or faces, what about privacy? You've got to have their consent. So you can't just go and scrape the web and download all this stuff, because you'll be in breach of the privacy rules, and then you get into all this ethical stance around where did you get your data from, and that provenance trail.
Yeah.
So data strategy, again, project managers, nice big long bar on your Gantt, because it's going to take time and it's going to require funding. It is non-trivial. Okay,
I'd like to just break a little bit and to make sure that anybody having questions, please put it up on the question answer session, and we can talk about that. There's also a poll that's out. Please fill that out while that's happening. Maybe we can. There were a couple of other things that you wanted to cover. I know we have 5 minutes, so maybe we can.
Yeah, well, you had been asked us for a little bit of like some takeaways, obviously, and I think in the slides, Andy put together that kind of cheat sheet that he was just showing. That'll be in the slides that folks can get. I think the other thing that might help with when you think about your projects, but also might help when you talk to your execs, because I imagine a lot of the audience here today are technical staff, is kind of like the iceberg, right? And when we think about AI, I think we often just really think about the tip of the iceberg here, these AI features. But there's a lot that has to go in when you start to do edge AI and tinyML in practice, right? You need to be able to manage these things. You need to think about how do you measure and monitor and deal with the results of that, right? It's one thing to measure and monitor, but then you're going to discover some customers or some conditions are worse, right? And then I think you need to start wondering, okay, how am I gonna deploy my updates? Obviously, if you're gathering data in order to deploy your updates, you've got privacy consent issues, right? So we dropped this into the slide deck, so you got a small version of it, but there's a free download available as well of the PDF.
Yeah, that's wonderful. It's kind of puts it all down on. It's a well thought out kind of process.
Yeah, well, and hopefully it's useful, right? I think as a founder, right, we've benefited from a lot of good help along the way, and those who went before us paving the path and giving advice. So hopefully we can share the field together.
We have a question whether you could talk about the sales cycle, TTM, and business modeling.
So sales cycle. Look, the good news is we're a software company. We don't have software overheads. The bad news is we sell to hardware companies, right? So we've got effectively hardware customer success life cycles. So that takes time, right? And that's got a lot of steps and a lot of phases to it. I think any big enterprise sales life cycle is going to be analogous, right? So to be honest, I would point you at the Andreessen Horowitz stuff online to really think about how to diagnose your sales cycle. What was the second part of that question?
The time to market and the business modeling.
Yeah, so time to market for any given customer, it depends really on where they are in their life cycle. So folks that are, near the end of being ready to launch product, that can go pretty quickly. If they're at the beginning of a consumer electronics planning cycle, that sometimes is a more than a year or even a multi-year life cycle. Our business model, so we sell our SDKs on a per camera license basis and the manageability platform on a recurring basis.
Okay. I think we are at the end. It would be great to continue the conversation, but I think we're at the end of the hour. So I'd like to really thank you guys for coming by and thank the audience for also showing up. And hopefully this will benefit some of the people who are developing these products.
Pleasure. Thanks for having us.
Yeah, thanks.
I'd like to thank our strategic partners, AIZip, Analog Devices, Arduino, ARM, Compass Marketing, Edge Impulse, Greenwaves, Grovity, IBM, ImageMob, Innovators, Microsoft, Nota AI, NXP, OctoML, Pauline Technology, Kixo, Qualcomm Renesas, Schneider, SensiML, Sony, Silicon Labs, ST, Synaptics, Xailient, and TDK. Sorry. Our executive strategic partners are Edge Impulse, Qualcomm AI Research, Xailient, our platinum strategic partners are Renesas, ITROS, hope I said that right, and gold strategic partners are Analog Devices, Arduino, ARM, and Infineon, Innovators, Microsoft, SensiML, STMicro, Synaptics. We have silver strategic partners, AIZip, BrainChip, Greenwaves, Grovity, IBM, ImageMob, Nota AI, NXP, Pauline, Kixo, Schneider, and Silicon Labs. Thank you very much, and hope to see you at the next tinyML builds.